Assalamualaikum and a very good day everyone. In this video we're going to look at how to configure if our input signal has specific bit pattern. Okay, so if you look at this pattern over here, this is our input signal for our digital circuit. Okay, so for those who just land in this video, so you have to look at the previous video to look at the sequence. Okay, so right now we are simulating output waveform for D flip-flop operation. So our input signal for the D flip-flop circuit that we construct is in this pattern. 1 or on. Okay, on, this is 5 volt. On, 0, 1, 0, 1, 0. So it's a regular pattern, isn't it? So, but what if let's say our input pattern, we want it to be 1, okay, 1, something like this, and then 0, 1, and then and then 0, and so on and so forth. Okay, so let's say our pattern is not regular, okay, not 1 0 1 0 1 0. So how to generate this for our simulation? Okay, so this is what we are going to look at in this video. Okay, so let's move on. Alright, so what we need to do is first, we have to look at our circuit. Okay, click on our circuit. So over here, if you look at our circuit previously, okay, let me close this first. Okay, if you want to close this, you click on the tab over here and then got this one. Okay, see? Got this close over here, so click on this. Right, then it will close the plot. Okay, so now you're left with this circuit only. Schematic diagram. Okay, so what you can do is first click on, because we want to change the data input pattern, isn't it? So click on, hover our mouse to this voltage source. Okay, once it turns into a hand pattern like this, okay, right click on it. Okay, so instead of choose pulse, if let's say we want to modify the circuit, modify the input waveform, okay, to be something just as what we want just now. Okay, so choose this one, PWFR. Okay, so what we need to do is we need to we have to construct, or we have to develop a text file that has the pattern of the signal that we want. Okay, so before we can choose this, okay, so we have to open up our notepad. Okay, so open up your notepad. So let's say like this. Okay, so I already construct the pattern. Okay, so in our notepad, it must have only 2 columns. Okay, where the first column okay, is the time, and then we have to space with some value that we want the signal to generate. For example, this is, I put 8, right? So let's say we put 5 volt. Okay, 5. And then what does it mean by plus 10 millisecond? Meaning that at 0 millisecond, the signal will be at 5 volt. Okay, 5 volt. And then plus 10 millisecond means for 10 millisecond, the signal will stay 5 volt. Alright. So next, if you look at this next value, here plus 0.01 millisecond, the value, let's say we change to 0. Okay, so it means that at another 0.01 millisecond, the value will be changed into 0. Okay, and we add another 10 millisecond, the value will stay at 0, for example. So the value will stay at 0 for 10 millisecond. So now we have 10 millisecond 5 volt, 10 millisecond 0 volt. So let's say we want our signal to be 1 0 0 1, for example. So what we need to do is, the next part, we have to add 5. Okay, add 0.0 millisecond to change it to 5, and then another 10 millisecond to 5. Okay, 5, and then the next value, let's say we want it to be 5 0, just now 500, right? So 5 0 0. Okay, 1 0 0. Let's say the next one is 1 5 5. Okay, 5 over here, 5. And then next is 0, okay, 0, and then 5, 5, okay. So our signal just now is 50 milliseconds, isn't it? The total waveform. So let's say until 5 milliseconds only we generate the signal. So this is 1, 2, 3, 4, 5, or until here only. Okay, so the rest is, we can delete this one. Alright, so this one, I hope you understand this. Okay, so from 0 millisecond plus 10 millisecond, the value is 5 for the output waveform. And then plus another 0.01 millisecond, the output, the waveform will be 0 volt. Okay, until plus 10 millisecond, another 0 volt, and another 0, 5, and 0. So our signal now is 1, 0, 0, 1, 0. Okay, for our input pattern. Okay, so save this. Remember the name of our text file. Okay, so save this, save. And then later on, remember the space where we put our data in. Alright, okay, so let's try out this. Okay, so here we already saved this. So let's say we save this. Okay, let me save this. Save as save as at desktop, for example. Okay, at desktop. So I have this. I save. Okay. So now let's browse to this file. Okay, browse, and then choose desktop, data in, and then open. Okay, and then okay, so give any names to your files, it's up to you, but it must be text file and it must be 2 columns. Okay, and then click OK. So once you click that, then you can see the name of the file for the input signal is given over here. Okay, so let's try out this. Click on run. Okay, and then add plots. Okay, so we add another 3 plots just now. Okay, and then choose the one that we want to see the waveform, data in, clock, and the up. Okay, so now we move the signal respectively. Data in should be here, data up should be here. Okay, so recall back, we have 5, okay, 0, 0, 5, isn't it? Remember? So 5005. Okay, so my output waveform over here, maybe you cannot see all, but now you can see all until 50 milliseconds. So 1, okay, 0, 0, 1, 0. So now the input pattern becomes as what we wish it to be. So this is how we generate input signal in a various form, not in a regular form just now. Alright, so I hope you can see this. Okay, and try out. Okay, and once you know this, then you can try out to simulate your circuit accordingly, according to the waveform pattern that you want. Alright, so yeah, I guess that's all. And I hope this video, you learn something from this video, and I hope you will learn. I hope this will help you to complete your assignment for question 1. Okay, thank you everyone. See you later.